Nice to meet you. My name is Kishida. Today, I would like to talk about the current state of Java frameworks. So let me introduce myself. My name is Naoki Kishida. I'm from Fukuoka, Japan, and this is my second time presentation at JCConf. So last time was I think 2015, 2014, around there, and so. I work at LINE Yahoo in Japan, and my X account is KIS, so please follow me. And so today's presentation, the source code text is very small, so please check the material on your device. So I already linked the material in the today's timetable. So and my blog is of course written in Japanese, but it is on Hatena blog. But I think you can read my Java code. So you only read my Java code. So I always write Java code, and I think Google Translate will translate. And and also I wrote books. We wrote books. So there is Sugiyama-san, the co-author of this book. So this is a very good book. So please read it once. And this is agenda. So I will discuss what kind of process the web server follows, and then explain the different type of web frameworks. And next, I'll describe how web frameworks have evolved. And finally, I'd like to talk about the current state of Java's standard. So let me explain what is a web framework. It's a server-side framework that abstracts the detail of web technology, so developers can focus on processing their application. So this is a very small source code, but this is a web server and written in Java. And so this is very simple implementation. But so a web framework is a mechanism that allows you to separate application-specific logic from this kind of web server code, so you can develop independently. By the way, this code has no import, and there is no class, but the code is completely run on Java 25. So in web development, the necessary process can be divided into 4 categories. So handling HTTP protocols, assembling web requests into an application, and managing the server itself, and overseeing the development processes. And so in handling HTTP, the request headers are processed and used to route to the appropriate application logic, and the result of that processing is returned. And next, application processing so includes the sessions or authentication or authorization. and managing resources such as database or files. So the operations that make up an application, and managing server itself is network administration, execution management, so like thread management, and setting, configuration, and monitoring. So monitoring means log or the telemetries. And finally, development management is a function that oversees development life cycles, including building and deploying and testing. So when we look at the order of processing in the source code from earlier, first, the network management, it prepares a socket that is on port 8080 and handles the socket when a request comes in. And when you do this properly, timeout handling or other such process are added. The management of execution is about how you allocate request processing. So in this code, I'm using virtual thread, and in practice, there are many other things to handle, such as managing the number of threads. As a configuration, for example, if you in this code, just listen port 8080, but we want to configure the port number. So in the server, many such configuration options, so managing the setting is very important. And so finally, there is monitoring. System is needed that can record logs or resource usage or elapsed time and other relevant information. So I will enter the HTTP processing. First, we handle the request headers. Here, we read the content of the request. After that, based on the information extracted from the request header, the server routes this request to the application process that will handle it. After the application process is finished, return the result as an HTTP response with a response header. So it looks roughly like this. And so I want to explain the type of web frameworks. So main web frameworks' main role can be described as simplifying what you do in resource response to an HTTP request. So there is three categories of web framework. So declarative or imperative, and component-based. So declarative framework is mainstream nowadays. So using annotations, you write the request and it's processing in a declarative way. And this style has so mainstream, so many frameworks using this style, so such as Spring Web MVC or AJAX-RS or Micronaut, it is an independent proprietary framework. And also Sublet is a declarative framework. So declarative form, so there are three frameworks, but it is almost same. So the Java code, except for annotation, is completely same. So message is different, but Java code is the same. And style of annotation is same, but name is a little different. So the structure is completely same. So for example, in Quarkus or Micronaut, you can also write things in a style, some style compatible with Spring Boot. Uh, and imperative framework handles requests and assigns processing imperatively. In Java, there are two frameworks, Javelin and Helidon. Helidon SE is a imperative framework. And for example, Golang or another language mainly have this style frameworks, I think. And so set up server and write methods that map URL and lambda expression for handling the request. So it is this style is very simple. So if you want to develop a very small website, I recommend this style. So especially Javelin. The final part of the web frame type is component-based framework. In this framework, you define UI component that are server-side logic and the user interface. So you assemble those components to build your web application. So because of this design, the server-side engineer can create the entire system, including the UI. And there are three component-based framework, each with its own distinctive features. So another two types, the frameworks are same, but in this case, three framework is a little different way. And the interesting is this style framework. They sell the special component with payment, and they can sustain their company to maintain the framework. So ZK is maintained by ZK Corporation, and Vaadin is maintained by Vaadin Corporation. And JSF, so do you know Prime Faces? Prime Faces is main component for the JSF. And component-based framework like this exists only in Java and C#, I think. And so the most representative component-based framework is JSF. And in Jakarta EE, it's called Jakarta Faces. In JSF, you write the processing in Java and define the UI with facelet XHTML. So Java code is essentially a POJO style. So there is no special API without uh, except for annotations. And the code can be quite simple, but when you try to control the web properly, it has some quirks. And I'm displaying the behavior as an animation, it becomes Ajax, so the view updates in place. So the framework able to write proper Ajax logic without writing JavaScript. It is very good. Yes. And it is a nice thing about component-based frameworks. And ZK is a very minor framework, but you write processing code in Java and define the UI with the proprietary XML format. And it's roughly similar to JSF, but unlike JSF, where values were handled directly in Java code, but ZK deals with components such as labels or text boxes without handling the raw value directly. So in JSF, so the Halloween have a string message or string input, and there is no special component relative field. But in ZK, there is a label or a text box. It is completely relative to the component and a special class for ZK. But so this makes control easier to manage. JSS feel a bit forced. And final framework for the component base is Vaadin. So Vaadin does not define the UI in a separate file, but define in Java. So it seems similar to Swing. And so I'll talk about how web frameworks have changed over time. Initially, Java frameworks ran on the servlet container, and later they moved away from using the separate servlet container and started running on the embedded server instead. And then people began developing them in Docker, and more recently, the concept of serverless. So in servlet environment, the pattern is start an application server and then deploy applications onto it. That application server is referred to as the servlet container. The context for this comes from the era when servlets first appeared around 1995 or 2000, when servers typically had only about 128 megabyte, not gigabyte, of RAM, even the server. So it is very small comparing today's standard. So with such limited memory, running many individual servers would be wasteful. So the solution was to spin up a single server and share its resource, hosting multiple applications on it. However, this approach made development more cumbersome. After building we have to deploy it into application server. And additionally, we have to install application server like Tomcat separately. So it makes sometimes make trouble. So in that context, cloud computing began to take off. So from the perspective of cloud provider, single thread performance had plateaued. So they need to increase performance by adding more processor core or servers. And for user side, consumer side, so cloud consumer side, 4G became practical, so making the network fast enough, not only for watching videos, but also for mobile streaming. And smartphone application performance improved, so as a result, traffic kept increasing rapidly. And so to handle the traffic, we solve it by scaling out, running many servers, each running, and each servers have a single application. So in that scenario, the design of servlet container that runs many applications on one server isn't suitable. So and in the time, the mechanisms becomes merely an obstacle. So Spring Boot appeared. So embed Tomcat into the application and start it from the main method and automatically deploy it. As a result, the framework incorporates an application server as well, so becoming a full stack, including server to application, so a full stack framework. And with embedded servers, the way of building have diversified. So previously, there was only one option, create a Java file and deploy it. Now we see many other methods, such as building all related Java files into FAT including the server itself, or packaging the JVM and wrapping everything in Docker, or even compiling natively. All of these approaches have emerged. So, and when multi-core and multi-server technology advanced, Docker and microservice emerged. As the number of cores grew and more virtual machines were needed to run them, it became apparent that launching many hypervisor-based VM on a single machine was wasteful, and thus came containers. Virtualized environments that abstract only OS resources, such as process ID or file descriptors. And with containers, assigning server process became increasingly flexible. You could split the system into separate services, allocate many servers to high usage functions, and bundle low usage functions onto fewer servers. And this is what microservices are all about. So as a result, the JVM startup speed becomes an issue. So in microservices, it is assumed that servers can be added or removed to much load. So until now, when you start an application server, it stays running forever. And so the JVM startup time was not a problem, but nowadays it is a problem. The other factors, such as starting the servlet container and speed of Spring DI is also bottlenecks. So with frameworks like Quarkus or Micronaut, so the dependency on servlets is removed. So by eliminating the servlet containers startup and resolving DI at compile time, so they achieve much faster launch time. So, and when you add more servers in a microservice architecture, each server becomes more fragile, building system that can tolerate individual server failures. So designing for resilience has become essential. And when you keep pushing the idea of splitting microservice by feature, each request ends up being handled by the single process. So that is what people call serverless. So in the past, there was something called CGI. Do you know CGI? So where a Perl script would be invoked for every request, like serverless. So I can say serverless is cloud native CGI. And so it turns out that not only the JVM startup time, but also the time until the JIT optimization kick in and make the processing faster became an issue. So even if process is started for request handling, once the request finishes, the process dies. So the JIT comparison may never complete before the peak performance can be achieved. So in other words, it ends up running slowly. That's why native compilation has attracted attention. However, the native compiler is somewhat inconvenient to use. So Project Radon began gradually integrating that feature into the standard. So JP 483 for Java 24. So it is class data sharing, and JP 515 for Java 25. It is なんだっけ I forget the word, but something is shared. So being added. So I think startup time will be shortened. And so the last topic, I will talk about what happened with the Java standard. The momentum behind Java EE disappeared, and for people who are concerned formed a group called the Java EE Guardians, which led to the transition to Jakarta EE. Along the way, microprofile emerged, and now we have Jakarta EE 11 available. So first, there is a discussion that the Java EE has lost its momentum. The premise of Java EE was the model of deploying many applications on the single application server. That model does not work very well in the cloud. In this context, Java EE 7 came out in 2013, but it should have included more improvements for the cloud, but it didn't increase its compatibility with cloud environments at all. Subsequently, development of the next version, Java EE8, stalled completely. Moreover, although Java EE had many advanced features, those advanced capabilities were replaced by Kubernetes. For example, you can now collect logs using Sidecar in Kubernetes. And because of this, Java EE's strengths have been eroded. So because development of Java EE8 was not progressing, people who are concerned about this formed the Java EE Guardians in 2016. As a result of their effort, Java EE moved from Oracle to the Eclipse Foundation, and in 2017, Java EE8 was released, and uh, in the same time, transitioned to the Eclipse Foundation. However, at the time, uh, name Java could no longer be used because name Java is owned by Oracle. So the, the name is changed from Java EE to Jakarta EE. So even though Java EE was stagnating, there was a demand for features that were particularly compatible with the cloud or microservice. And therefore, before the Java EE Guardians even emerged, microprofile was created as an interim solution to support microservices. It places emphasis on monitoring and fault tolerance. Microprofile is built upon Jakarta EE's core profile. So the core profile includes JAX-RS for web services, but doesn't include sublets. So it is independent of the servlet API, and this allows developers to move away from the traditional deploy to servlet container model. So when you look at the API, microprofile API, it includes features such as iterating server status for telemetry, standardizing description of Open API and Server API, specification, and providing a client for calling REST services. Because microservices require common configuration, how to manage these settings is also quite important. As a resilience mechanism are built in, such as timeout, retries, and circuit breaker. Circuit breaker means when the operation fails repeatedly, so the circuit breaker stops processing temporarily. And JWT authentication, JSON Web Token-based authentication system, and health check, so ensure the server is actually alive. And the final topic is Jakarta 11. So it was released in June of this year. So the minimum Java version is now 17. And so record class being used more actively. And also it is not part of Java 17 itself. Virtual thread is partially supported. And this is a diagram of Jakarta EE. And the smallest profile is called core profile. So it is not include servlet. And the standard one is a web profile. And when you include everything, you get the Jakarta EE platform. So this is all of my topic, but I have more 7 minutes, so I had to talk about MCP server. I think you interested in MCP. So MCP is a specification that defines tools intended to be called from LLM AI, and it's internal remote object based on JSON RPC. So since Spring Boot and Quarkus supports MCP, I'll give a brief introduction. So in an example code, this is define a weather tool. We create a method called get weather that returns fine if the location is Taipei and rain otherwise. So the method is annotated with tool. The annotations description says gets the locations with a, and its parameter is annotated with tool param, which explains that it represents the location. These annotations are intended for Spring Boot, but in Quarkus, you use same name tool for method and different name tool arg for the method parameter. And I have 5 minutes, so I can live demo for the MCP. So there's a NetBeans. So so this is the code I showed before. There is a get weather and to annotate it with a tool, and there is a tool farm for the parameter and type A, fine, and otherwise rain. Only this is required, and but in Spring Boot, so this is register the tool. So return type is tool callback provider, and method tool callback provider builder and tool object for the tool. The tool is injected to this parameter. So this is only we have to do to develop the MCP with Spring Boot. So and this is LM study also, and it's run GPT OSS, so OpenAI's open weight model, and いやー、あ、ちょっと待った。動いてないので。はい。So I'm launched the MCP server, and in the LM Studio, there's a configuration of MCP. かな。So sorry, the font is very small, but so MCP servers Spring AI with SSD. This is a name we can freely define. And URL http localhost 8080/SSE. So finally, and there is違う、これがログじゃなくこれか。And research. So if you want to see, please come. And so get weather is registered. And so So I activate the MCP in this prompt. And I input what's weather like in Taipei. So if I'm lucky, the LLM will invoke my MCP server. So yeah. Now GPT OSS is considering to and now confirm I can invoke the MCP. So then weather in Taipei, condition fine. Enjoy your day. So another version. Time is up. So yes. So なんだっけ? Enjoy your day. So thank you. Yeah, it is all of my contents. Thank you.